Hello, welcome back. Myself, Professor Amit Fartale. Today we are going to study the chapter number 2, mechanical properties of the fluid, which is the remaining part. Okay. First, we study the measurements of the pressure. The instruments which are used to measure the pressures is called as pressure meters or pressure gauges. It is also known as vacuum gauges. Then mercury barometer. As shown in figure, there is a mercury barometer. The mercury barometer is used to measure the atmospheric pressure. It's called as barometer. The first barometer was invented by the Torricelli. That's why this barometer is also known as Torricelli's barometer. In this, a glass tube is upside down into the small dish which containing of the mercury. The glass tube is in a 1 centimeter in a diameter and 1 meter in a length. The vacuum is created at the end. It's called as Torricelli's vacuum. It also contains the mercury vapors. At point A, there is no pressure. That's why pressure at A should be equal to 0. And point B, C are at same levels. That's why pressure at B is equal to the pressure at C. Therefore, pressure at B is equal to P0, which is the atmospheric pressure. Okay. Suppose at the point A, below the height h, PV is equal to PA plus h rho g. H be the height, rho be the density, g be the acceleration due to the gravity. Equation number first. Okay. As we know, pressure at A should be equal to 0. Therefore, put the value in equation number 1. We get PV is equal to h rho g. Okay. Equation number second. But PV is equal to P0 be the atmospheric pressure. Final equation, P0 is equal to h rho g. Next, open tube manometer. We are going to study the open tube manometer. In open tube manometer, it consists of U-shaped tubes which are partly filled with the low density liquids such as water or the kerosene. In these, there are two arms. One arm is open at the atmosphere and another arm is connected to the container D to measure the pressure. At the point A, atmospheric pressure P0 as shown in the figure, and point B and C are at the same level. Therefore, pressure C is equal to pressure B. Okay. At the point B, pressure is given as follows. Pressure PB is equal to P0 plus h rho g, as we see previous one. Okay. This is the open tube manometer. One end is open, one arm is open to the atmospheric pressure and another end is connected to the container D, from which we have to measure the pressure at the point D, where rho be the density, h be the height of liquid column and g be the acceleration due to the gravity. Let C and D be the same level, are at the same level according to the Pascal's principle. Therefore, pressure P is equal to pressure C. PD is equal to PC is also there. From equation 1 and 2, P is equal to P0 plus h rho g be the equation number 3. So, we have to find the gauge pressure at for the container D. P0 transferring to the towards the P. P minus P0 is equal to h rho g be the equation number 4. Next is the surface tension. A liquid at the rest shows some interesting property. That property is called as surface tension. Molecular theory of the surface tension is as follows. One by one we study the important points of the molecular theory of the surface tension. In this, intermolecular force, the matter is made of the molecules. Matter is made of molecules. Any two molecules attracts each other. any two molecules attracts each other, that forces intermolecular force, the force of attraction is known as intermolecular force. There are two types of intermolecular forces. First one is cohesive force and second one is adhesive force. In simple language, we study both the cohesive and the adhesive force. Look at this definition: the force of attraction between the molecules of the same substance, and in this, the force of attraction between the molecules in the different substance. We have to change only same and different. Means cohesive force, the force of attraction between the molecules of the same substance is called as cohesive force. Example, the force of attraction between the two air or two water molecules. It is strongest in the solids and weakest in the gas. The force of attraction between molecules of the different substances is called as adhesive force. Example is the force of attraction between the glass and the water. Next is range of molecular force. The maximum distance from the molecule up to which molecular force is effective. Molecular force is effective is called as range of molecular force, which is in a few nanometers in the solids as well as the liquids. It is also, that's why it is also known as short range forces. Next is sphere of influence. The sphere of influence as shown in the figure, A, B, C be the sphere. It shows the sphere of influence. An imaginary sphere with the molecule as the center and radius is equal to the molecular range is called as sphere of influence. Okay. Next is surface film. As shown in the figure, X, X dash, Y, Y dash is called as surface film. The surface layer of the liquid with the thickness which is equal to the intermolecular force, range of intermolecular force is called as surface film. Fluid in the motion. The branch of physics which deals with the study of properties of the fluids in the motion is called as hydrodynamics. The branch of physics which deals with the study of properties of the fluids in the motion. If it is in a motion, there is called as hydrodynamics. If it is at rest, it is called as hydrostatic. Okay. One by one we study the types of flow. Steady flow is there from the figure. Flow line is there. All the lines are parallel to each other, means they are traveling in the same line. In this, the measurable properties like the pressure and the velocities are remain constant. That flow is called as steady flow. Okay. Streamline flow, or it is called as laminar flow. The steady flow in which the adjacent layers moves smoothly over the another is called as streamline flow. It is also known as laminar. Laminar means along with the same line. Turbulent flow. Turbulent flow, it is defined as the flow in which with the high flow rate, so that there is no steady flow and the flow pattern changes continuously, means the fluid molecules rotational motion is in motion. So differentiate between the streamline flow and the turbulent flow, which is asked for the 2 marks. First streamline flow and second one turbulent flow. Definition: the smooth flow of the fluid with the velocity smaller than the critical velocity is called as streamline flow. The irregular and the unsteady flow of the fluids when the velocity increases beyond the critical value or the critical velocity is called as turbulent flow. Streamline flow, the velocity remains constant. In this, they do not remain constant. The two streamlines never intersect each other, they remain parallel to each other. At the some point, the fluid behave in the rotational motion. All the streamlines will be in the parallel to the axis of the tube. The particles move in the random directions. Next is, what do you mean by critical velocity? The question is there for 1 mark. Define critical velocity. So answer is as follows: the velocity with which the streamline flow becomes turbulent flow or changes to the turbulent flow. The velocity with which the streamline flow changes to the turbulent flow is called as critical flow, critical velocity. Reynolds number. According to the Reynolds, the critical velocity is given by Vc is equal to Rn into the eta, this stands for eta, upon rho into the d. Equation number first, where Vc be the critical velocity, Rn be the Reynolds number, eta be the coefficient of viscosity, rho be the density, and d be the diameter of the tube. So equation 1 can be written as the follows: Rn is equal to Vc into the rho into d upon eta. Equation number 2. It is a pure number. Reynolds number is it is also known as a pure number. That's why it has no units and no dimension. It is a dimensionless quantity. If Reynolds number is less than 1000, the fluid flow is streamline flow. If Reynolds number is greater than the 2000, the flow of the fluid is turbulent flow. If Reynolds number lies between 1000 and 2000, the flow of fluid is unsteady flow. Thank you. For the next videos, please subscribe our YouTube channel and get the interesting videos. Thank you.